timber can be used only where there is no water contacts, and also if we are using basements, we cannot go for timber construction. So we were analyzing the buildings that we were actually trying to construct. What is the amount that we can try to maximize in terms of using timber for construction? And fortunately, we were able to achieve at least 55% of the building footprint to be constructed using timber. This is called mass engineered timber. And this, of course, also could lead to productivity gain and also reduction in terms of the construction time frame. No doubts that it's also a sustainable source. Likewise, we also tried to explore on other elements of the building, and the other element was the facade. We started looking at how we can have the facade constructed in a modular way, and we started exploring, trying to do many mock-ups to understand how challenging is it to do the construction using a modular way or system. And because we are dealing with timber and modularization, we also wanted to have or prevent welding works when we are using steel frames. So we also posed this challenge to our consultants to say how safe the steel structures can be erected in this premises. So the consultants came with innovative solutions to offer bolt and nut connections with minimum welding on site that led to achieving a safe construction on the ground. This is another interesting topic which will be dealt in detail by Prakash later. However, in a bigger scale, we call this as enhanced passive displacement cooling. SMU has already been researching on passive displacement cooling systems many years before we even started venturing into this project. And as part of passive displacement cooling, we have tested few spaces in SMU campus to see how well the displacement cooling system is behaving. And we took this project as an opportunity to enhance the system further by integrating all the other services and systems with the air conditioning systems. And it was modularized as one system, and we call this as enhanced passive displacement cooling module, which comprises of all the mechanical, electrical, plumbing systems along with the air conditioning system. And the systems were actually tried to be tested to see how well this can be coordinated into this design, and also try to understand the productivity gain, construction time reduction, etc. And we did see that this has the potential to be implemented in this project. Of course, because we are already going for modularization, we could also try to integrate the smart control components into it. So each modular panels will also have the smart controllers integrated, which means that the systems that are being operated for running this building is going to be monitored throughout the day to see whether the energy is only used up in the space where there is a need and where there is no wastage of energy within the building itself. So this integration allows us to run the building and operate the building in a smart manner. And we have all the systems located in the Fire Command Center at one location. So the system is being monitored by the FCC guys in a constant basis so that we can always be mindful about how the energy is being used for this building. Of course, since we are trying a lot of new technologies, we were very concerned about how to build this. So we used BIM as a tool for us to integrate all these systems together. And the first building was built using BIM. And the second time it was built physically. So we always say that we build the building twice. Using BIM technology, the building was built in the first time where the consultants were actually trying to derive the design solutions using BIM models, integrated the different systems, and also handed over the same BIM model to the contractors who could further complement the BIM by doing the interface drawings, coordination drawings, and follow through with submitting the shop drawings and then proceed with the actual construction using the original BIM model itself. This also helped us to understand the clashes and also try to minimize the clash during the point of construction, because we cannot afford to have any mistakes while we are in the construction phase. As much as I spoke about the energy savings aspect, we also focused on the renewable aspect. So we also try to introduce the best high standard photovoltaic panels in the roof. So this allowed to generate certain PV generations in the roof of the building itself. What it means is the energy that is being generated in the roof is equivalent to the energy that is being consumed for the building. So, from the original target of Green Mark Platinum, the building was elevated to net zero energy status. And because the energy panels and the photovoltaic panels are on the roof of the same building, we are also saying that on-site generation is equating to the on-site consumption, and so is the on-site net zero energy building. Of course, being this is also like 45% better than a green mark platinum building. It speaks for all the targets and achievements. We have also got the HGBC Leadership Award for the Singapore Management University's campus building, because we are also chosen for business leadership and sustainability for transforming on how we operate the campus. And the SMU Connection building also has achieved the leadership and sustainability carbon performance. Not just that, the building overall has achieved almost 17 awards so far in international context. It has also achieved the ASEAN Energy Award for zero energy building category. Of course, the ASEAN Energy ASHRAE standards, etc. So we have seen the high level information. This is something that is more on groundwork. I also wanted to show this because this also gives a feel of how the project team had executed the project during the phase of construction. So what you see here is actually the BIM model where the simulations were done for in terms of the structural elements, in terms of the connection details, how it's going to be erected, all those things were simulated during the BIM exercise. This is also a portion of the BIM model which actually shows how much of the mechanical and electrical plumbing systems were coordinated, how many areas can actually go for modularization, and how this can also act as an aspect to be used for the purpose of fabrication. So this is actually a view of how the different modules were fabricated. And there was also a need for inspection, so we had to usually send the people to the different factories to also do the inspections, because once it is delivered, it directly goes to installation. As the site does not have any storage space, from the factory, it directly goes for installation. That means that there should be zero tolerance for errors during the fabrication and while it's being installed. The facade mock-up was very handy and very useful because the mock-up is the one that led us for the learning to see what are the mistakes that we should not be repeating while we are fabricating and while we are going for actual physical works of the building erection itself. So for the sustainable construction, every element of the building had contributed towards the sustainability in terms of manpower savings, in terms of productivity gain. And in a range of 20 to 45% is the contribution uh, of all the elements to achieve this productive improvement in terms of the implementation itself. As much as we have seen this, this has also been translated into the time frame that the project has achieved in terms of the gain in construction time. Originally, the project was conceived to be developed or constructed for a period of 24 months. Of course, by going for modular construction and by adopting various sustainable building materials, it has also led towards a reduction in terms of the construction time frame. And so the building was delivered in 15 months, which was just nice as it was completed in October. We could do the TNC and also other teething issues were actually handled. And it was just timely for SMU to start the operations from January 2020. So these elements actually led to the successful delivery of the project pre-COVID and post-COVID, which is the phase two building. Because all these elements or structures and buildings were coming from different parts of the world, the COVID had minimum impact in terms of construction phase because the buildings were constructed at different parts of the world at different phases. And while once the relaxation of the COVID, these parts came back to Singapore and we started to assemble and we were able to successfully deliver the project in the desirable timeline. As much as I've spoken about the benefits that SMU has achieved out of this journey, what we have done to the globe is what we can see here. In terms of how we constructed this building, the embodied carbon aspect itself has reduced the carbon dioxide emissions, which is actually equivalent to planting 1,823 trees to the globe. And the way it is being operated, because it's being operated in a very sustainable way, it is also contributing to a reduction in the carbon dioxide emissions in a yearly basis, which is equivalent to releasing at least 45,000 trees every year to the globe so that these trees can contribute towards removing the carbon dioxide from other sources, which is undesirable. So that is the significance of the two projects. Of course, there is one more challenge which we had to face, which is actually constructing this bridge, which you can see in this photograph. This bridge is actually on top of the road, as I said earlier, and originally it was planned to be completed in a span of 100 days because the construction can happen only at night time when the roads are allowed to be closed, and it has to be the construction works have to be stopped at the daytime because the roads have to continue its operations as usual. However, for this 100 days, we are also putting the public in at risk. So what we had to go is to introduce such sustainable, creative, productive way of construction to our agencies and persuaded them to allow us to close the road just for 7 days. And the bridge structure and the key elements of the bridge was completed in 7 days that allowed us to complete this bridge structure in a very seamless manner and also try to have a, a proper successful closure of the project. All that I mentioned here has been summarized in a video which actually spans uh, across a 15-month journey of the construction of this project. Hope you enjoy this video. Let me share the video. Well, that ends my presentation, and hope you guys enjoyed it. Thank you.
Yeah, that is wonderful, Bharti. We have few questions from the participant. I have few questions.
Sir, we can go for a Q&A after Mr. Nadraja's presentation as well, because
Okay,
these two presentations are combined.
okay.
So I think Mr. Prakash will be presenting now.
Yes, thank you. Thanks, Bharati. Hope you can hear me, right?
Yes. Let's go.
Okay, let me share my screen. Can you see the screen?
So it's visible, sir.
Go
Okay,
ahead.
great. Okay, let me go through that. Bharati is covered the overall journey, and I'm going a bit more detail about more on the energy optimization and the energy consumption quickly to show that journey to achieve the net zero energy building. I hope I will answer some of the questions is already posted in the chat. You are very much focusing on what is the EUI, the energy usage index. Someone is posted. I will go through that quickly, and then we will tell you that what are the challenges we face to achieve the net zero energy building. So I will cover quickly the what are the passive design strategies, and followed by that active design strategies and building energy consumption, and how we maximize that renewable energy generation on that on-site roof, and user engagement and awareness, and then finally the conclusion. Okay, so this is a site is already like a the site boundary is like a fix, so is to maximize the building footprint. You can see that the building is follow the site locations. So what we have done the solar shading analysis to minimize, first of all, to minimize the heat gain into the building. So we have done the solar shading analysis, and then the facade optimization simulations. This one is to achieve, of course, you can see there is a cell shading effect. The blue color mean is a very low the solar exposure area, and the red color is fully exposed to the sun. So we minimize the facade area which exposed to the sun. That is the first, the energy reduction strategies. We closely work with architect and client for the facade optimizations. So just to summarize here that first of all, to optimize the facade is a bit tricky because we have to minimize the heat gain. At the same time, we have to provide the view and maximizing the daylight penetrations to minimize artificial lighting energy. So is all, and then of course we have to meet the architectural design intent. So in first place, we optimize the window to wall ratio and provide the double glazing unit where the glaze is, and then provide the shading element to shade the glasses to minimize the direct radiation. We have like an insulated wall and self-shading foam. These all will reduce about 50% of the 50% of the solar heat gain into the building. In Singapore, we measured it called like ETTV value, the envelope thermal transfer value. The baseline here in Singapore is about 50 the watt per meter square, but we reduced to 25. It's almost 50% is less. The second one we have in the layout plan, you can see that green color area is a naturally ventilated area in the along the facade, and then all the air con area is inside. So how we design it. For the naturally ventilated space, we have done the CFD simulations as these the SMU connection is located in the city in Singapore. Is a very dense building. We cannot just rely on the predominant wind direction. Of course, we have run the CFD simulation for like a 1 kilometer radius to understand the airflow around the building. To maximize the wind flow in the naturally ventilated space is mainly at the ground floor and the external corridor on the other floors. So here the CFD simulation, you can see the zoom in result. So very good natural ventilation we achieve at the level 1, where the most of the naturally ventilated areas are there, and followed by that the passive design for the to maximize the daylight penetration and incorporate with the artificial lighting design. We have a daylight zone. The zone is about 4 meters from the facade. It's having the different the light zoning and the control system. There is control system along the daylight area is with the more occupancy sensor and also the lux sensor, but the internal area, each of the zoning is controlled by the occupancy sensor. And this more important, this project is very unique, and the innovative design features is about the air conditioning system, how we design that air distribution system. So before that, we can see that we are used by reducing the cooling load of the building, having optimized the passive design. So we reduce the cooling load of the building as much as possible. This help us to tap that chill water from the existing chiller plant. So which also is a very efficient chiller plant, is 0.5 kilowatt per RT. The benchmark in Singapore is about 0.7 kilowatt per RT. So it's a very efficient chiller plant we have. Then for the air distribution side, we, as Bharati mentioned earlier, is the innovative system called enhanced passive displacement. The passive displacement is not the new, is typically is used for the high volume spaces with a cavity wall to bring the cool air to that occupied spaces. Even the SMU, Singapore Management University, they have the passive displacement ventilation for their sports school, is implemented for a long time back, about 15 years. But the passive displacement for the typical floor-to-floor height is the first time implemented in Singapore. We designed the module accordingly to meet the requirement to bring the cool air to the occupied level effectively without any fan. Of course, we have the fan for the fresh air supply, which controlled by the CO2 sensor. But for the distribution, air circulation, there is no fan. This one is purely on the conventional method, like cool air is sink down and then the hot air will rise up. We use that system. You can see there is a modular system we develop over the time, and then is finally installed in the SMU connection building. So you can see the principle here. Yes, is a fresh air. Fresh air also is like we filtered but not pre-cooled. So is a outside air is filtered by various filters to remove the dust and particles, and then at discharge near the coil, which cool and remove the moisture from the fresh air before it blow down into the occupied level. So how it works that there's a double coil displacement unit is on at the ceiling, and where is air is cooled and then is directed with the small down duct is inbuilt within a module. So you can see that I will show you the simulation result later. Then of course a heat generated from the occupied zone and the lighting, then the air get warm and is circulate back to that ceiling level, and the cycle is happen again. Again, that hot air will cool down with the chill water coil at the ceiling, and then the cool air is directed down through the down duct inbuilt in the PDC system. So this cycle is repeating. How we achieve the air circulation without any fan? This one is achieve help us to achieve the net zero energy target and reduce the air circulation energy consumption. So To control the indoor air quality, of course, we have a CO2 sensor and the relative humidity sensor, a temperature sensor to control the temperature, then occupancy sensor as well. And then these air conditioning, the passive displacement units are like, we have like a zoning system. So it works based on the occupancy sensor as well, based on the demand. So how we reduce that air conditioning demand and air conditioning energy in the space. Yeah. So here you can see the simulation result. The blue color, dark blue color, mean is a very cold air, is about 16 to 18 degree. The air is directed down with this small down duct on the both side, is directed down to the occupied zone. You can see the arrow how the air is passively is moved according to the heat load generated. Then this is the temperature at the plan view is achieving about 24 degree. That's our design temperature at the occupied zone. So this is a final product. What you see is a initial design is you have like a very long down duct, and then is reduce the down duct with the optimization, but we minimize to about 200 mm space is sufficient to bring the cool air to that occupied zone. That's the final product. As I mentioned earlier, that the fresh air is just discharged at the near the coil. So you can see the red color is the hot air is discharged about 30 to 33 degree, and at the occupied zone, is cooled down before it come to that occupied zone. So at the ceiling level, of course, the temperature is higher, and then is at the occupied zone. You can see we achieve the desired temperature what we need. So, I mean, it's design, the simulation is simulation, what we have verified with thermal camera and other the tools to ensure that what we have simulated and on site is how it works. You can see that at the occupied level is the space is cooler than the ceiling level in the real project. So we tested that outflow temperature from the coil, and then what's the air velocity, all this tested. And we achieve the benefit, this energy efficiency and the uniform airflow. That's more important because conventional system, you can see that people who are sitting below the diffusers feel very cold because the air speed is very high, and then bit away from the diffusers is slow. But here we achieve the uniform airflow and low maintenance because the condensation is over on the chill water coil. There is no fan, so is the coil itself is clean over the time, and low maintenance. Save spaces because there is no AHU room in the space. As Singapore, you know, every square feet is a very expensive, so we save the space. And noise free, as I mean, in the air conditioning space, if you have the ducting system, airflow, at the very high noise, but here that we reduce the noise because we are supplying only the fresh air through the minimized ductwork and the long life. Of course, the system is a DFMA framework, the whole modular system. So with that, we achieve about 91% of energy efficiency in the air distribution system compared to the Grima Platinum building in Singapore. So with that, other strategies, of course, also important, the lighting, mechanical ventilations, and the AV system. I will go through that quickly with that zoning control, having the efficient LED lighting. Our lighting density is about average, is overall is 4.3 watt per meter square, while we are achieving the 500 lux. So it's a very efficient lighting design with the efficient LED light. With the occupancy sensor control and lighting sensor control, of course, we have the schedule control as well. These all linked to the BMS, so we could monitor the energy consumption and the zoning control, which achieve 45% of the energy saving compared to the Grima Platinum building. The AV system is quite common because as a university to facilitate the classroom requirements, there is quite a lot AV equipments, so which consume the energy for longer period. So what we have introduced, like a normal case, they have like an active mode and a standby mode. We introduced like another mode, like a cold standby to power off that the unnecessary equipment in the AV system. So it saves a lot of energy for overall. It's about 27% energy saving compared to the baseline energy consumption of the AV. So you can see that here we are showing compare the platinum building. If you build the same building in the platinum standard, so this is the energy consumption, energy breakdown. But with the green color, you can see there is our SMU connection building. So for the AC plant, we achieve about 48% energy saving. Lighting, as I mentioned earlier, is 45. The AV equipment is overall is 58% energy saving. Air distribution is a great energy saving, about 91% of the energy saving. So with that, the overall we achieve 46.4% energy saving than the Grima Platinum building. Grima Platinum is not the baseline. Is a Grima Platinum is 30% efficient than the building, but we are much higher than the baseline building. That's why we compare with the Grima Platinum always. You can see the energy breakdown, how we estimated even before we build the buildings, but then monitor. We could monitor all this energy breakdown in this building because that's very important for the net zero to monitor and maintain the net zero energy consumption of the building. So we minimize the energy consumption. As I mentioned, the EUI, we achieve 73 kilowatt hour per meter square per year. We have to note that this building is operate 79 hours per week. Is much higher than the normal office, like a 45 hours per week is operating hours. This one is almost like a double, and one of the floor is operating 24/7. The level 2, because there's a student collaboration area, study area, which operate 24/7. So these all energy consumption is offset by on-site solar PV installed on the rooftop, because only the solar PV is economically viable in Singapore context. So we maximize the PV power generations, having the opaque PV everywhere, and at the same time make sure the daylight penetration in below the solar veranda by having this. So total PV generation is estimated 560.7 megawatt hour, and then energy consumption is reduced to 549. So is from the, because this project is start with the Grima Platinum design standard. So because over the design improvement, we bring it to bring lower down the energy consumption 46% to achieve the net zero energy building. So this is a data you can see is a real the energy dashboard data. So there's a detailed breakdown for the energy metering. We can monitor every level, every disciplines. So based on the 2021 data, you can see there's a energy surplus. We generate about 79.56 megawatt hour energy more than that consumed by the building. So whatever the extra we generated is goes to the grid. So how the system is works. So during the daytime, when the energy generate more, it connected to the grid, and whenever the energy at the night time is import from the grid to the system. So it's a net metering, but at the end of the year, we achieve is a 79.56 megawatt hour is a surplus. That's my last slide. Thank you.
Thank you so much, Mr. Prakash. Vijay sir,
Yeah.
over to you.
Is Martha there? Yeah, man. We have seen your presentation. That is, I think, wonderful. I would like to have know the difference between the cost of construction between the regular pre-cost or prefab construction compared to this, and what is the life of this building? And you have used photovoltaic cells. What is the life of photovoltaic cells? So you need to change them after every 10 years.
Okay. So, Mr. Vijay, I've asked so many questions at one go. So, let me take it one by one. If you ask for the cost, definitely there is a cost increase for this building, but there is no one-time solution or answer as to how high the cost has been, because different elements of this solution has different cost increase. For example, the CLT has contributed to almost 20% increase in the cost, and the PV, the passive displacement cooling leads to almost 15% increase in cost. But in terms of operational cost, there is almost 95% savings in operations of the air conditioning systems. So it depends on how beneficial is this in terms of why you have to adopt which technology, and you have to equate to the gain that you're achieving out of this implementation in your context. Does that answer your question?
Yeah.
The next question on photovoltaic panels. When we have actually purchased the panels under our site, because we have not gone for renting it out, and we have only looked at the deterioration ratio, and we have also tried to compute the deterioration ratio for the next 3 years, because we have got to have a commitment to achieve this as a net zero building for the next 3 years, which has been guaranteed by the suppliers that it can still be efficient for the period of next 3 years itself. In terms of the duration, maybe Prakash, if you have any information on how frequently we have got to go for replacement, I will
Yes.
listen.
For thanks, Bharati. It's about expected is 20 to 25 years life for the solar PV in Singapore. Yeah. That's the guaranteed period.
So what is the preparation of, see, I think we have seen the presentation right from the groundbreaking and until the completion of a project. So what is the preparation time before actually you start the actual construction?
Okay, let me take up this. The preparation is the key, and we have got to also strategize the way we are preparing, because we didn't have much lead time to have the luxury of starting it from day one, as we foresee this to be a sustainable construction. If you notice, we started off as conventional construction. So we had to start in a designated time frame, because we had the time to deliver by 2019 October. That was the target. So when we started off, we started to face the different phases of the building project. For example, piling, how we strategize, and also certain elements that are coming from overseas. For example, CLT that is coming from Austria. The time that we have got to place order is at least 6 months before we have to inform them about this, and we have got to go through the shop drawing from the overseas factory. So we have got to prepare at least for a 6 months timeline, so that we can be just nice in terms of delivering this. The facade elements are coming from multiple countries. We have got assembly in Malaysia. The glass is coming from China. The timber facade is coming from Netherlands. So the first exercise, what we did is the timeline that will be required for each of the components was what we tried to understand. What is the last that we have to confirm so that we can have this delivered by the time we want it to be delivered. So this reverse calculation was done for every element of the building to the extent that we know that there are totally 1,470 facade panels, and we had to also monitor every facade panel's fabrication so that it can be just on time for the delivery to the site. So the preparation is the key, but the motivating factor for the project team is we spend more time during the construction phase so that you don't have to prolong the project and you don't have to keep meeting again and again for the project for a longer duration. So we were trying to be more efficient and effective during the planning stage so that pre-planning helped to deliver the project on time.
Thank you. Anish, do you have time to take questions in the chat box?
At least one more question we can take, and then we can go for next session, sir.
Okay. So there's a question from Swasti. What are the key or crucial challenges faced by the project and its key takeaway or lesson learned, which can also address similar issues globally? Assuming we are a combination of participants from different parts of the globe, please highlight the lessons learned, which is not project specific.
I would want this question to be a bit more slow in terms of while you're reading it.
They want to understand the crucial challenges faced by the project.
Okay,
And the lessons learned.
Okay, the crucial challenge is we didn't know what we don't know because it's a new technology. We were preparing for all that risks that we already know that this will be the risk, right? So we had backup plan for all the risks that we will know. The aspects that we didn't know is what we didn't know. That's what we have learned through the journey after we have completed the project. And because this is coming from different parts of the world, we have also got to work on the details that they expect from us for different information. For example, for timber, they expect every slab sizes to be confirmed to us upfront. Otherwise, they cannot produce or fabricate it upfront. And because there is a lead time for fabrication, which is at least a month or 2 months, and there is a lead time for delivery, we have to be very precise in terms of the detailing. So that is one of the key challenge which will be universally wherever we are implementing this project. Detailing and trying to be precise is one of the key aspects that we have got to focus on. In terms of challenges, because we are also dealing with timber and Singapore has extreme weather in terms of rain at any point of time. So while you're dealing with timber construction, the timber will always be exposed to rain. And once it is already soaked in water, you have got to wait for the time it dries off before you go for next level of construction activities on the timber. So this is another challenge that it comes to timber itself. Yeah, likewise, there are other challenges for different elements. So if there is any other things that there is specifically to different element, I could probably answer specifically.
I can add on that. Thanks, Bharati. It's a key takeaway. I mean, as a consultant in this project, if we have a target to achieve that the net zero or was a clear ambition to achieve, in the proper like a coordination with the teamwork, and is talk to the client as well. Of course, the client set the target. We are achieving the net zero. At the same time, we have to meet the like a client requirement as well in terms of the air quality, operating hours, thermal comfort is a various element. For net zero itself, we cannot design like a for naturally ventilated area as much as we need. So in this project, what we learn is a very well team coordination, consultant talk to the client, and then we discuss the challenges and we overcome with the that there will be a technical solution, and then while we are meeting the client requirement. So we have to open discussion. We have to start early, even during the concept design, to meet the final goal. Thanks.
Thank you, Bharti and Prakash, for your wonderful presentation and inputs. So, over to Anish.
Okay.
Thank
Yeah.
you. Thank you so
Thanks.
much,
Thank you.
both of you. So we can
Thank you.
begin the second session now, sir.
You. Thank you, guys.
Thank you.
Best
Thank you,
wishes.
ma'am.
Thank you. Bye. Bye.
So you can introduce our second speaker as well, sir.
Yeah. Welcome, Suraksha Acharya. Mrs. Suraksha graduated with honors from the School of Architecture and Planning, Anna University, Chennai in 2007. She went on to practice at TR and Eanes SDM Bahad in Kuala Lumpur under the mentorship of Dr. Ken Young. She was closely involved with the design phase of several large-scale mixed-use residential and commercial tower projects in Asia that were driven by sustainable concerns. She has Masters in Sustainable Environment Design program at the Architectural Association, AA, London. She has worked with the startup firm Omarai Studio in Singapore as an architectural designer. She pursued her passion for green as a sustainability consultant with the Design Partner Architects in 2013 and as a green building analyst with Environmental Design Solutions in 2014.
Hi, thank you so much.
Yeah, okay, Go ahead.
Should I start I'll just share my screen?
Yes, ma'am, please.
So can you actually see my presentation?
Yes, ma'am, it's visible.
Okay, so
Yes, ma'am. Thank you.
all right. So thank you, IGBC and CII team, for advancing the net zero building agenda in India. I'm very happy to be invited to represent my firm Midori and talk about our net zero building project as a case study to the green building fraternity. Hello, everyone. Pleasure to meet you virtually. I'm the founding principal of Midori Architects, and I live and practice from Chennai. So Midori is an award-winning firm established in 2016, and we basically do a lot of sustainable architecture. We provide architecture interiors, green building certification, and sustainability consulting. If some of you are wondering what Midori means green in Japanese. And true to its meaning, we believe there lies an element of inspiration through the green approach in all projects. So this is just a kind of a snapshot of a couple of our projects. We do a lot of residential as well as commercial, multi-use, hospitality, and also apart from this, to keep our creative juices running, we do invite ourselves to participate in competitions, which keeps it always very exciting. So today I'm going to talk about what it is to be a net zero building. Net zero buildings is an important step, as you all know, to reducing the greenhouse gas emissions and mitigating climate change and creating more of a sustainable future. The image that you see here are all the things you can do from a passive design approach to a building in order to reach that end goal. In other words, it's a building that can help not only produce the energy to cancel out or zero out the amount of energy it takes to operate that building daily. As architects, the use of passive design strategies is extremely important to creating sustainable design that is environmentally responsible. So this is kind of what a net zero building you could expect to see. It takes care of all of the elements that you see in your screen now. And I will move on to how we have addressed this in this particular project. The project I'm going to show you is a residential building for a three generations of family, and they came to us with an agenda to create the most sustainable home you can ever dream of. And we are a firm, they've come to the right firm, because we are a firm that is committed to using not only evidence-based design approach and advanced technology like simulation techniques, etc., to produce architecturally pleasing work, while also pushing the boundaries of performative concepts and building science. And we use that in our decision-making and thinking. The name of the project you're going to see today is for Bauer family, a great family living in the heart of Chennai. I think in another life, Mr. Bauer is probably a sustainable architect. I've never met someone such as a client like this who's so enthusiastic in adopting sustainable solutions and new approach, which is very refreshing and exciting for the team and a perfect client for Midori. We were asked to design a house across 3 floors with 9 house guests, about 8,000 square feet in 1.5 grounds. It should be the first of its kind and produce a very breezy, eco-conscious kind of a feel. So the house itself is located in a corner property. You can see there are 2 roads over there, and the red color is the corner plot. The image you saw here was the image before we demolished the existing building that existed there. We wanted to create not only a sustainable escape, but a smart zero energy residence for these clients. And it was set in 1.5 grounds. This building is an IGBC Net Zero pre-certified design building. We are yet to complete it in about 2 months in order to complete the full certification. It's also important to say that the 50% of your energy saving happens through design. And it's very, very important as architects to know the science behind what happens to your building once you do place it. I've been on the architecture side, obviously, because I am dealing with the clients directly. I take their design brief and we work as a team to give them their vision, bring their vision to life. I've also worked on the sustainable consulting side, where as a consultant, you give your points of view after detailed study to the client or to the architects. And sometimes what happens is it is too late. By then the design is already decided. And so it's very, very important from day one, you are part of the core team to really push the sustainable agenda. Having said that, I'm going to kind of go across our form development process. The first thing that you would notice as soon as you come to India.
Yeah. Can you please go for presentation mode, because I see chat requesting for this to be in presentation mode because the image is too small.
In presentation mode?
Yes, now it's better because previously we could see the notes beside it.
Okay. Anish, can you see it now?
Yes, ma'am. It was smaller actually. Yeah.
Okay, now is it fine?
Yes, yes.
Okay, so the first thing we need to do is make sure that the Vastu is taken care. So first thing as an architect, you'll have to know is that Vastu sometimes, it's a science, building science, where it sometimes does conflict with the environmental aspects that is needed to bring it to zero energy. The site itself is 45 degrees, not true north, not true south. So it's already 45, and so it is not 100% Vastu compliant by virtue of its orientation. Given that, we had to choose, considering there were neighboring buildings on either sides and 2 roads on these northwest and the southeast side, we had to choose the next best option in order to create our entries. The two green arrows that you see here are the entry and the exit that you see that was decided for this particular plot. Also in the corner, there was a chamfer. And as per Vastu, that is something that we basically don't pretty much like. So we have to kind of cut off that chamfer from a design perspective. And hence that 1.5 grounds we had to work in maximizing the FSI for this still +3 building. And keeping the FSI allowable was about 2. And we tried to maximize with all of the requirements that was needed, given these two abutting roads were there. We were able to kind of come up with a skinnier footprint with a 1 meter setback on all 3 sides and a 3 meter setback in the front. So that would be the shorter side being the front. We ended up with a building that we were going to build. We decided to build still +3, which is about 12 meters. And one thing that we very early on had to do was understand what the orientation is doing to the form, and the fact that the building itself was 45 degrees northeast and northwest and southeast was actually a good thing environmentally, because you are not receiving direct radiation in any one direction. It is kind of an inclined radiation that you're receiving on the front facades, which is something that ended up helping us with our net zero agenda. And the green approach was always the highest priority in how we kind of looked at the design approach. Also, we had to look at the prevailing wind directions. And we early on had to keep that in mind, because we know that with natural ventilation is one of the few most effective strategies that we can use in order to reduce the consumption. However, in hot humid climates and tropics like in Chennai, we are not always so lucky in an urban context to get constant natural ventilation, probably as you go higher up. So that was another challenge that we need to look at in how to control and quantitatively assess this natural ventilation, which is one of the strategies apart from avoiding the heat gain. We studied the prevailing wind directions from all of them, keeping the weather data, etc. in mind, north, south, west, and southeast for Chennai, and the frequency of occurrence as well. So in the north, you would have the most occurring winds at 12%, south, you would have 10%, west, you would have 8%. But as you have from the southwest and southeast, the wind velocity magnitude was higher, which is about 3.1. Keeping all of this data in mind, we kind of set about starting the design. And one thing in terms of energy efficient design is the overall form that we spoke about. And what you see here in white is the flow plate. The flow plate itself, the big chunky box was kind of scooped out to create what we would like to call our natural ventilation, something like the lungs, a kind of scooped out in a portion which on either side, so that the big volume gets segmented into 2 larger volumes. And this will kind of, the idea behind this was to create a flow plate where the wind scoop will enhance the flow through these spaces. If the windows were operable in the case of natural ventilation. And as you replicate these flow plates across 3 floors, a still +4, for example, you end up having something like a large vertical atrium. So the only thing is a semi-enclosed atrium. It's not an atrium which is enclosed entirely inside the building, so you won't see stack effect, etc. But it does end up working like a wing wall, where you can actually scoop in the wings through aerodynamics and Venturi effect. You could actually scoop it in and allow it to pass through the other side through negative and positive pressures. Great thing about this atrium as well is that it ended up giving us views out, which is one of the main aspects on what to capture the main viewpoints, which was pretty much northwest. And also in terms of the central green space, we kind of adjunct it with the core. So we know that northwest is receiving a lot of solar radiation from the initial mapping, and so putting a service like a core, which is not going to be used 24/7 in daytime, for example, a bedroom, it was helpful because it did end up taking care of buffering that zone. This is the spatial layout. You see these different colors which was basically adding the spatial functions to all of the zones. The core remains gray, the green space in the center, the orange being the semi-private spaces, and the purple being the private spaces. So what you see here is pretty much the form. And in terms of the overall massing, what we next wanted to do is to rotate the overall form by 12 degrees in order to enhance this aerodynamic effect that we are looking to do. By doing this, what we are trying to create is more wind venturi effect and scooping happening on the inside. And doing that, keeping that as a central axis, we also ended up twisting and scaling the block, for example, trying to pull out the floor plates a little bit to create an umbrella effect. What this umbrella effect ended up doing is creating self-shading to the building. So the higher you go, the larger the floor plate, and the lower you go, the lesser the floor plate. So it pretty much created that umbrella effect. And we are also committed to generative design process using fundamentals of parametrics, and to come up with the right scaling and the degree of rotation, we use visual programming as a means to do this, keeping the site as context. So this kind of helped us experiment and explore different options and see which one would work best in order to give us the optimum rotation angle and also the optimum kind of FSI and the massing based on the site and the client brief and etc. So this is kind of a small form development process. This was the shading that we were talking about, creating that umbrella effect, which was something that we intentionally wanted to do. You're looking at the incident solar radiation here on watt per meter square. Once you do, what we do regularly is to test and evaluate the form throughout the design development process. So make sure that we're not off on the performance target before we've gone too much into design and it might not be the best option. So here we kind of looked at the maximum radiation in each of the inclined facades, so northeast, northwest, southwest, and southeast at different times of the day and times of the year. And we ended up noticing that both the volumes ended up shading each other at different parts of the year and different parts of the day, which was a useful thing and helpful in terms of creating an envelope that does not have a very high direct gain. What you're looking at now is the flow plates. Once we were convinced we had the right massing, we ended up extracting the flow plates and the canopy into a semi-permanent solar panel. On top would be a roof. So what you see on top is a double roof where we would put the solar panels. It was considered to be a semi-permanent structure on top. These are the columns and framing and beams that we were added when we had the structural consultant on board. We made sure that the architectural form and the framing as well as the columns all worked out to align towards the green approach which we were looking. These are the walls that were added, windows, and of course the floor plates. So the floor plates that you see here in brown is nothing but the balconies. The umbrella effect ended up becoming such that after the setback, they ended up forming not only outdoor spaces like balconies, but also ended up useful in an environmental aspect, the fact that they were actually shading the building. You're now looking at the handrails and then the actual cladding on the exterior of the building, and of course the screen that you're seeing on the right side, the screen wall. We also developed a large screen wall on either sides. One was to kind of reduce the for the privacy of the staircase area, which was what we showed before, and also for the aspect of creating privacy apart from just shading. We ended up again using a parametric method in order to develop how much of perforation should be apt for the screen. For example, when we wanted more less amount of radiation to come in, the porosity of the screen would reduce. And when we wanted more radiation to come in, we would, based on the radiation mapping, the screen ended up determining how much porosity in each area would be allowable or permissible. On top of this, we are proposing a green wall, which pretty much will be and put in an ACP material and also cut to add to the frame. So I'll come to more of this later on down. In terms of the top, which you see is a double roof. In this roof, we're not only planning to clad it with steel sections and use Fundamax panels, which is also an Austrian product, because it's a replacement. It's basically craft paper and a replacement for using wood directly. And in this particular view, we decided to use laundry panels, which has a bifacial one. So that's what you see here on the right. So we are doing on-site renewables in this particular project. And what you see is the final developed design. In terms of the window fenestration, we had a choice to do straight windows, or we had a choice to do inclined windows with a slight curve. Obviously, doing an inclined window is a little bit more complicated than just making it a rectangular straight window. But however, looking at the umbrella shape and looking at the aerodynamic effect of the building, we felt it was apt in terms of fenestration to give an aesthetic of a slant versus an aesthetic of the straight aesthetic. So this is kind of what you see as the final elevation that was developed. Again, back to more testing. We are looking at the solar insulation. So we basically put the building on a grid, and we wanted to kind of test with and without shading what would be the real effect of adding these balconies. And to our surprise, if you look at the, one second. Yeah, can you see my screen now? Am I audible? Yeah, you're able to see the screen now, right? Yeah, so if you can see the table below, what we ended up noticing is with balcony shading, we were able to bring a large number of the contour points within a percentage, which is higher points brought in within a lower percentage to a lower intensity. So that was something, as you can see, all of this blue, for example, is the effect of having these balconies as a shading element. The screen, of course, also creates a direct radiation screen reduced significantly, and you can see that from the blue. In terms of daylight, we made sure that we used a lot of lighter colors in the ceiling and also on the floor. We use Makrana marble, which is more of a white shade. We already have segmented the building, so we don't have very deep floor plates. But with some spaces like kitchen or maybe the corridor somewhere in the middle, we wanted to make sure that the reflectance values and the glazing VLT value worked out such that the interior spaces got as much daylight as possible. So here you're looking at the analysis grid in September 21st. Again, this simulation basically tells us we have a bit of lighting, more of it in the periphery, and it is sufficient. More than 99% is greater than 110 lux on all 3 floors. This is the 3rd floor. In terms of airflow, again, testing to validate back to the same, architectural science and understanding how the building performs. We looked at the 4 prevailing wind directions and ran simulations, CFD simulations. These simulations basically help us understand that if the wind is coming in a specific direction throughout the day, what will the interior look like if all of the windows and the doors were kept open? Considering this is a map that you see at stilt flow. Obviously, stilt flow is more open, so you're going to see colors in a higher range of 0.6 to 1, etc. But on the 1st floor, we are experiencing some spaces that don't exactly have full cross ventilation. But we are noticing also that the atrium that's in the middle does help create that venturi effect that the whole premise of this design had started with, which made us quite happy and interesting to see. And also same with the second floor. Again, this is coming from the south. So from a different direction, it will be, the kitchen which you see here in blue would be getting a lot of ventilation as well. Whatever's on the windward side, you can see is actually helping bring them through the spaces and create that cross ventilation that we want to do to meet our net zero targets. This is the terrace floor plan. Another interesting thing that we understood that is with and without screen. So we ran the same simulation for with the screen, the big three-story screen, and the ones that are on the second floor and on the terrace floor. The screens, and to see what difference it actually made. And what we kind of noticed is there was more of there was a better flow with the screen because of the negative leeward side and the negative pressure it was kind of creating. So that was something that was kind of showing that the design was a little more successful than we expect. So on the left side was with screen and the right side is without screen, and you can actually see how the values differ, keeping the same input parameters and the boundary conditions exactly the same. These are just more sectional slices to kind of understand what's happening in that middle area where we are seeing a lot of ventilation and air movement happening. As long as the occupants open the windows, we should be able to expect a scenario like this. Obviously, tomorrow, if there is going to be a lot of dust or a lot of sound, or for whatever reason, if they don't end up using the window, we the results that we're hoping to receive is not going to be there. So a lot of it has to do with the willingness of the occupant to engage with the building as well. These are some of the architectural plan layouts along with some views of each of the spaces. This is the first floor plan where you have the bedrooms, kitchens, dining, and toilet area. This is the second floor. This plan has gone through many changes in terms of having a toilet and not having a toilet, etc. But mostly overall, it's remained 90% the same. This is the third floor plan that you're looking at. In terms of energy efficiency and materials, I just wanted to go through, run you past what choices we've made. In terms of the landscape, this building is not only net zero, but obviously green homes. It's also gone in for IGBC green homes. And so not only did the client just want to show that the rating system is working towards what the goals of the team are, but also the fact that we want to be more than the rating system. And so we made extra care to make sure that the landscape, even though there's this really small site and we really don't have much space, we try to utilize the landscape vertically, but whatever we could do horizontally, we chose drought-resistant species and paver blocks that would percolate the water inside. So in terms of the choice of the rainwater sump that we had was to capture 100% of the rainwater. We have about at least 12 percolation pits of different sizes, and wherever we are using paving, we're making sure that we use paving that will not help run off the water that is captured. In terms of the building envelope, we're using Aerocon blocks. A U value of 0.6 was calculated and estimated, and so we all the walls were made internally and externally of Aerocon and plastered. In terms of the building envelope, the glazing is has a U value of 1.6. We've used double glazed KS146. It's laminated and it does have I think a 45% PLT. From inside, here it's looking green because we had to cover the windows for protection. But you can actually see the frame of the corner curve window, how we have made it with UPVC. This UPVC vendor actually had an environmental product declaration, which helped us analyze his life cycle from cradle to actual site. So this was something that was quite exciting, and a lot of the UPVC manufacturers in the first, I mean, a lot of them rejected, saying, hey, you know, it's not possible to make these curves. It's just too much of crinkling, and it's not going to work. And with a lot of R&D and a lot of persuasion and a good vision and a supportive client, we were able to actually install these windows. So all of these windows are now installed at site. The energy efficiency, in terms of energy, we did really pick the equipment very carefully. There are 3 VRFs there. Also, the heat pump that we've used, we made sure that we are still trying to find ways in which we could use the exhaust air from the heat pump, which ends up being cool, if we could kind of pump it into the air conditioning shaft, into the lift shaft, to kind of keep the cool of that particular area, which is a common space. The elevator that we used is Hitachi, which is also an energy efficient one in terms of equipment. In terms of materials, we try to source as much as possible locally. But of course, sometimes in the house, it's your one-time house, it's not possible to source from here. A lot of these tiles and ceramics do come from Europe. And so even when we are picking them, we are making sure that the companies in which we are working with follow responsible environmental practices. The balcony itself, we're using Fundamax. We're using tiles that you see over here on the balcony, but for the vertical cladding, we are using Fundamax. So Fundamax is nothing but craft paper that's kind of compressed to make a very durable, hard exterior cladding product. It comes from FSC certified forests that are grown to harvest the wood. And we were able to trace the origin and find the right person, and we are using that for the cladding. So in the render, if you do see a light wood cladding, it's actually through the Fundamax. And right now, that's what we're using for the undersoffit and for the side of the beams, which has been coming out quite well. Also, the railing, we're making sure the railing follows the form. So if you see these dark wood railing, the railing actually has 4 types. It's which is quite exciting for the design team. We have the opportunity with this client to experiment, and so we have a glass railing, we have a Fundamax dark wood railing, and then we have a single leaf railing. So kind of combining all of this and the mock-up that you can see on at site over here, we had to work out the detailing such that the exterior of the building looks like it's slanted, but the functionality and safety of the railing still remains by having the handrail in the normal position that one would expect it. So that was exciting. The building envelope itself, also the roof, we ended up doing brickbat Koba along with cool roof tiles, which has which was kind of the first. We planned to have some turf, and throughout the journey of the project, you know, changes and decisions get made, budgets get inflated and deflated, and so we finally ended up going with cool roof tiles on the roof, which you can see there is laid. And this is the screen. The screen is actually, the framework for the screen is done. It is in the shape that we have envisioned it. Also, we are using HPL sheets to actually do the CNC cutting and the modularization of the grid and the fabrication off site, so it can come and be installed, on which we would wish to see the green wall kind of creep. So we are in the process of that mock-up. In terms of the solar capacity, we're looking at a 24.5 kilowatt peak, which is possible from 54 panels. We have chosen Longi, which are bifacial, and the fact that we have a white roof below the panel actually helps reflect the radiation and actually increase the energy production from the panel. The panels have all been bought, and we are in the process of installing them. We are using inverters, 3 inverters, because there are 3 flats, and so we're kind of channeling all of the production, and we're using net metering to do the import-export. The client doesn't wish to use a generator. We have electrically provided the use for a generator, but we haven't bought the generator and we wish not to buy a generator, and we're still assessing battery technology, which is in the very nascent stages. There are V-flow batteries, there are batteries which are lithium ion, and we all know the life cycle of these batteries are only 7 years, and the V-flow battery is for life. So there's a lot of things that we are in the discussion, and every time we make a decision, a new technologies change. And so at the moment, we are in the process of figuring out if we could be not only net positive, but also off the grid, which was quite exciting. We've done this energy simulation. Here's baseline versus proposed case. And through all of our incremental changes, which is a proposed case with the balcony shape, with a good VRF system with a COP of 3.2, with the external jali or the screen and the COP of 3.2, with the updated schedules of the client, that means when are they occupying the building, when are they not there, because it's a house and there are multiple occupancy, each one has a different time. And if we did kind of look case by case how we could incrementally reduce this energy consumption, we're looking at about a 56% reduction from base case. And with the production of solar PV, we are at net zero. And we were very, very excited about it. These are just more images of the occupancy schedule and the set points that we use. The set point we've used is 24. However, we can't really say what in reality people will put. They may put 21, they may put 23, and we are so excited to see them occupy it so that we could actually run the real data and actually do the actual math to understand what is anticipated and what is actually at site could be calibrated, and we're looking to learn more from that. In terms of shading, you're looking at a graph which says total cooling load with shading and without shading. And you can see with shading, it is much less. And so architectural enhancement at the early on design stage is the most, I think, the most powerful thing that we can do in order to meet the net zero case. This is the final render of the building that you're seeing from the southeast entry. We are looking at different shades of Funamax as well as interesting windows. We want a modern, contemporary, but also a compact structure that has all of the on-site generation that it requires to sustain it. This is the annual energy use from baseline to proposed with the breakdown of lighting, equipment, and the cooling. So we were significantly able to reduce the cooling in terms of with passive design strategies alone. The kind of equipment we've chosen, whether it's 3 VRF units, and also the profile of the coefficient of performance. We have got an energy consultant on board for this, who helped us through the way in terms of picking the right equipment. Also, in terms of the fans, we made sure we use DC fans rather than AC. This building is net zero energy pre-certified platinum, and it's the first residence in India that is got this rating, and we're very, very excited about it. The net zero case, we just wanted to show that as much as we have done R&D and reviewed the data and the statistics on our side, we are quite excited to actually start with the occupancy and take all of that data and share it live for more case studies to learn from our experience and journey. This is the actual building, just a model view to kind of show how much water that we reuse. We have an STP, a sewage treatment plant, a mini packaged one. We have rainwater 100%, so 160 liters, 62% is being reused for the green vertical landscaping, as well as for the other landscaping on the ground. We're generating 38.9 megawatts totally in a year. The EPI is 0.77. We have 56% of energy efficiency. And we have a green cover of 58%, which we're very excited about. This net zero, we've already received net zero platinum pre-certified design and on our way to get the final design. I want to very much thank the people who everyone has worked so hardly and tirelessly on, from energy consultants, HVAC consultants, MEP consultants, renewable consultants, our structural team, and most our architects. And we are also the green building consultants. We have another wing called Midori Green LLP. And of course, our dear clients, without whom we won't be in this fantastic project. We are also going in for IGBC Green Homes, and we have been awarded. And once we do submit the final documentation, we are very confident that we're going to achieve that certification as well. This is just some in-progress views, and by December, we're hoping to have all of the scaffolding pipes out and have the building ready to go. I just wanted to kind of show a few images of the site in progress, and we're hoping to have more of it ready as soon as the final construction is over, which, as mentioned, end of November. This is the final vision, and we're hoping that this vision would inspire more, and we could learn more about how it is to reach the net zero case in the context of an Indian subcontinent, and how we could, challenge ourselves to go more than net zero, perhaps in zero carbon. So this is another home, which I'm not going to go into, but the question arises is, are we happy with net zero? Can we not go into the next, what is net positive? What is zero carbon? And so this is another home that we are doing in Chennai, which is a zero carbon home, which is going in for a different certification lead. And in this particular one as well, similar processes and approaches were used, but the product is very different. And here we've really looked into materials in terms of embodied carbon, how much cement we could reduce by using GGBS. We have experts like concrete mix design experts who helped us. And what the real learnings is, it's not possible on our own. We need a huge team to help us. And all the stakeholders in this industry play a very important role, from property managers to contractors to clients to engineers to architects. And at each stage, when you talk about material or carbon, at each stage, each one has a different level of priority. And I think the architect can definitely help bring everybody together and make sure that we use the right decision making at the right time, so that we can reduce our overall benchmark. So we have done a life cycle analysis for this particular building, and we're very excited to publish the paper soon. And in this particular building, we are 500 kilograms of CO2 equivalent. So that is the benchmark which we have received for the entire shell, which includes the windows, the walls, and the structure itself. So knowing such information helps us track and monitor, and gives us a yardstick from which we could keep comparing and becoming better and better in all of our projects. And residential projects, we have the freedom to explore and the budgets to explore, which is always exciting. And that's it for me. So I hope if you want to know more, please visit us on our website and our Instagram page. And I'm ready to take questions. And thank you so much for this opportunity.
Wonderful, Suraksha. I think Suraksha means safe. You have given a safe building for your client.
Thank you.
I would like to introduce Mr. Venkatesh Pai.
Good evening, everyone. This is Venkatesh Pai.
Anish, it is not visible. Screen.
Hello.
Yeah, please hold on, Venkatesh.
Yes, sir.
Yeah. So I have stopped sharing my screen, right?
Yeah.
Okay.
Now, Anish is trying to share the profile of Venkatesh. Welcome, Venkatesh Pai, co-chair IGBC Mangaluru chapter. Mr. Venkatesh Pai is a partner at Pai Lands Associates. He's an architect and engineers Mangalore with 7 years experience in the field of architecture and design. He has teaching experience of more than 15 years. He is director at the Canara Workshops Limited, Mangalore. Mr. Venkatesh is director at Astatic Infrastructure and Design Group. He is the treasurer at Indian Institute of Architects, Mangalore, Manipal chapter. He was the winner of Ultratech Outstanding Residential Villa Awards for 2007 and 2017. So he was awarded with Outstanding Young Person in the field of Architecture and Engineering in Mangalore district in 2002. So over to you, Mr. Venkatesh.
Good evening, everyone. Actually, among all the questions, thank you for the presentation, Suraksha. Very nicely done.
Thank you.
Hello.
Sir, you are audible, sir. You are audible.
Yes. Okay. So, thank you for the presentation, Suraksha. We have a set of questions here which people have been asking. They mainly have to do with two issues. One is what are the key points to note when maintaining this building, and how do you plan to address this with the owners? That's one question. Suraksha, can you answer that?
Sure. So the two questions that you had is how we plan to maintain the building.
No, the first question is that how do you plan? What are the key points in maintenance of the building? Because there are 3 or 4 questions which are talking about how do you plan to handle the maintenance of the building and how do you plan to do it with the owners?
Okay. So the owners are very much in line with taking care of this so to say baby of theirs, which they have been envisioning for a long time. In terms of the maintenance, I can only see the landscape being the most important one. The fact that we do have this green screen, which is irrigated through drip irrigation, we have designed it in such a way so that the plants can actually be accessed from the ground level. And as the screen goes up, they have ways in which they can prune it. Otherwise, we do have annual maintenance contracts with those specific VRF machines and other vendors and stakeholders whom would be able to help us monitor if something went wrong or if the system was, for example, needs to be recommissioned or tweaked or calibrated based on the actual reality scenario. It's for us, I feel it's not going to be an issue because I do know the clients. It's not like any ordinary house, it is the house of the future.
Okay. The other question, which is there are about another 4 questions regarding this, is what is the software you're using? The big question is software, and what is the software you're using to get all this data done?
Okay, outside. So in terms of software, we do use a lot of parametric and computational tools. One major one is Rhino and Grasshopper. If you are one of the new age architects, I'm sure you will know about this already. It's a great, very powerful platform. You could code it to the way in which you want to see the results or get the results. And through this software, there are many plugins which you could use for your environmental simulation.
Can you repeat the software again? Can you repeat the name of the software again?
Sure. It's Rhino, and one of the plugins is Grasshopper.
Yes.
Along with that, you do have different other plugins to, for example, understand the wind simulation or understand your airflow, understand your solar insulation. So there are many, many plugins that help you analyze data real time as you are generating the model in your platform. So it's extremely powerful and useful for students and professionals.
Thank you so much. Manish, I think that about wraps it up.
Yes, sir. We can conclude this session.
Yes. I would like to thank Suraksha Acharya, first of all, for a beautiful presentation. Thank you so much.
Thank you.
And very nicely articulated. and I hope the project comes out very well for you.
So do
I
we
would
hope
like
to
to
have IGBC there taking a tour also with us?
I would like to thank IGBC for this for organizing this program. I'd like to thank Vijay Sai for the introduction and the preliminary works. Thank you so much.
Thank you so much. Thank you all. I hope everyone have enjoyed the session. So the today session is about to end. So we can I think
I have one
say
question,
goodbye.
Manish, for Suraksha.
Please, sir. Please go ahead.
So it seems you have put your heart and soul into that project. So you have given full presentation about the project. So what was the cost per square feet?
So the cost per square feet is, with construction and interiors, we're looking at 5,500 per square feet.
Okay, without interiors?
You're looking at about 2.5 to 2.8. So before COVID, it was slightly different, and now it's a little bit more.
I think it is very reasonable. I am a builder in Hyderabad.
Okay.
So the cost actually, you have shown so many features with 2,800. I think it was efficiently designed and constructed.
Thank you. Thank you
And
so much.
2008 it's the steel.
Okay.
Okay, bye
Thank
everyone.
you.
Thank you so much.
Thank you, everyone. Thank you. Bye. Bye, sir.
Bye.
Bye.
Thank you.